I didn't post until like literally 3 seconds ago. Their posts for today. What's funny is that you were in that meeting. Never mind. I was going to say, what's funny is that I didn't even know it was today, and all of these other districts have early dismissal, blah 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 blah. I don't think. I think it would have gotten called if it was should have gotten called. Morning, Ian. Capsize. Max is here. Cameron, Max. Hi guys. Let's open up our slideshow for today. Cindy, I have to take my scarf off because it is so warm. Good morning. And Gwen, Naseem. We're just waiting on Peyton, Ava Z, Adam, Kyle, Janessa. Very cool. Okay, Kyle is here actually, so I don't know why I just said Kyle. Good morning, good morning, good morning, good morning. I'm going to start to share my screen. Let me just, on my end, make a copy because Miss Shermaine has to do that. File, make a copy of the entire presentation. We're going to call this C1, and here we go. So please open up the slideshow for today. We're missing quite a few people today. I don't know like why that is, but like I guess it's a thing. Let me just, yes, sorry Gwen. I was late on the Zoom link, sorry guys. But thank you for making it in. I was stuck chatting with Miss Sisson, but not chatting, because chatting implies we weren't doing work, but we were doing work, I promise. Let me share my screen and we're going to get started. So I'm going to do this where I'm going to pin myself and I'm going to go like this. And then I want us to look at, Ava Z is here. I want us to take a look at our lesson day. So before we get started, we're going to talk about this new topic that I like to call, we like to call functions, okay? And functions are, I like that this is sort of falling right after this equations unit because functions and equations are pretty, they like functions, going into functions from equations is a very nice sort of progression because we're using this concept of equations, and now we're looking at these equations and we're designating whether or not they fit this criteria of this of a thing called a function. Okay, so let me get to the slide where we're going to talk about what these two this concept means of a function. Okay, and I think once we sort of talk about it, get a little bit of discussion going, we're going to have a pretty good time going through this. So let's take a look at first slide number 2, where we're talking about this concept of a function. And a function is an equation, really, we're going to be looking at an equation that has each input, x value, has exactly one output, okay? So when you have, for example, y equals 2x plus 3, when you plug, let me just let Adam in, sorry guys. So when you plug a value in for y, you're going to get exactly one output value of x. You're also going to, and then it's sort of counterintuitive where if you plug a value in for x, you're always going to get only one output for that y. Okay? That's number 1. Also, another aspect of being a function and not versus not being a function is if you have an equation that, for example, if we look at y is equal to the absolute value of x, okay? If you take in this equation and you input, this time we're going to input a y value, If we input the number 2, what are we going to get as an output? What's the absolute value of 2? The absolute value is always going to be positive. It's that distance from 0. So it's going to be 2. And then if I input this value of -2, what's my output going to be? It's going to be also a +2. So a piece of function versus non-function is that another piece that's important is that when you have an input, you can't have 2 different inputs that have the same output. So you can't have 2 different inputs. You have a 2 and a -2, which both have an output of a +2. So it's every input has exactly one output, and it can't have duplicates. So like if you have 2 different outputs, they can't have the same output. I'm going to talk about it more on the next slide. Okay. So let's take a look at an example of a function first. Okay. So examples of a function. We have this guy here, this table here, where we have an input, number of output, the number of sides, right? So you're inputting a shape, you're outputting the number of sides. Okay. So for a triangle, we have 3 sides. For a square, we have 4 sides. For a pentagon, we have 5 sides. Hexagon, we have 6 sides. Each one of these inputs has only one output, and there is no repeating sort of piece to it, right? So if I, for example, had this idea of a pentagon, a parallelogram. How many sides does a parallelogram have? 4. So if I add this concept of a parallelogram into this table, would this now be a function? Why? Okay, because each input has a different output. Give me 1 second, Peyton. Because there's 2 different inputs. There's a square that has an output of 4, and then there's the parallelogram that has an output of 4. Let me stop my share and let me try it again, Peyton. 1 second. Okay, can you see it now, Peyton? Still no? Can anybody else? Oh, you can't see, so everybody can't see what I'm writing on the board. No. Okay. Very cool. Give me 3 seconds to sort of problem solve this. Okay, I have a question now. I'm paused. 1 second, 1 second. Try this one more time. Now? No. Oh, okay. So, okay, that's okay. We're gonna keep moving forward, but just know that when we're talking about, if I were to, for this, if we're looking at this guy here, so you see how I just sort of boxed around this table here. If I were to add a row at the bottom here that said parallelogram, it would have 4 sides. Then that would make it not a function because we have 2 different inputs that have the same output. If you, for example, in this table, again, put square and then 4, it would still be a function because we have the same input, just it's repeated twice. Okay? So then if we're talking about an equation now, let me just click on this next one. So we're looking at the equation, which is to the right-hand side, the right-hand picture here. We're talking about inputs and outputs. Okay? So our output is designated the range, and our input, x value, is designated our domain. Okay, I'm going to be talking more about this today in the activity, okay? I'm on slide number 3. Can you guys not even see the slide that I'm on?
Maybe leave the meeting and then go back into it.
Me?
Yeah.
I know, but I don't, but then they'll be in there all alone.
For only like a second.
Okay, so let me try to do what I'm going to try that. Listen, I'm going to leave the meeting for like 3.3 seconds. Please do not leave. Do not leave. I'm going to just leave the meeting. Someone is going to become the host. I'm going to make Abby Wassa the host for a second. Okay. Hi. Okay, let's try that again. I'm going to try to share my screen. Let's see what happens. I'm going to go to, I want this guy here. We're going to share it. Can you see slide number 3 now? Let me know in the chat. Perfect. Yay. Connor, you're the best. You are literally the best. Let's see. Yeah, let's see now. This is the more important part. Can you now see my drawing? Yes! Success. Connor, you're a brilliant person. I literally should never question anything you said, and I don't, but I'm really proud of you. Okay, here we go. Let's take a look at non-functions now, okay? So now we're talking about non-functions. And non-functions there's 2 possibilities, right? So for each X or input, there is more than one output. So when we're talking about, for example, if we were to, this is not an example of not a solution, because this isn't a function. So we're really focusing on this second piece down here, where you're talking about different inputs have the same output, is really what's going to take you to have a non-function. Those are primarily the examples we're going to be looking at today, okay, and in this unit, okay? So non-functions are when you have different inputs having the same output, okay? So let's take a look at our first activity for today, okay? So here are some numbers in a list, okay? So there is 1, 2, 3, 4, 5, 6, 7 numbers here. How many different numbers are in the list? Oh my gosh, I just answered my own question. 7 numbers are in the list. Good. Now, what I want you to do with each one of those numbers is I want you to square them. In each one of these boxes, you're going to take the corresponding value and you're going to square it. Use a calculator for yourself to do that out. You're going to take 2 minutes right now to do that for me. If you finish early, talk about how many are in the new list and explain why these 2 lists do not have the same number of different numbers. Did Adam make it in here? Yes. Okay, we're taking another 1.5 minutes, guys. You're doing great. You're putting, well, you need to square the number. So you take this 1 here and you square it. You take this -3 and you square it. Multiply it by itself. Does that make sense, Peyton? Perfect.
Mr. Reynolds, please call extension 1114.
Okay, let's come back together. Let's take a look at what we're talking about here. Okay, give me 1 second. I just need to get over to the board. Okay, so what did we get when we squared 1? Very good. Nice job, Connor. Squaring the number 1, 1 times 1 is 1. Very good. Now, Junior, what'd you get when you squared -3? What kind of 9? +9, okay? And why'd you get a +9? Very good. When you squared the -1/2, what'd you get? Kyle Kelly? 0.25, or you could rewrite that as a fraction of 1/4. Good. I'm going to write the 0.25 above it, okay? Now, let's look at that 3.
Kansas, please call extension 3211.
John, what'd you get when you squared 3? 9? Okay, let's see. Gabe, what'd you get when you squared 2? Very good, 4. Abby Wasta, what'd you get when you squared 1/4? Very good, Gabe, thank you for that. What'd you get when you squared 1/4, Abby Wasta? You can put it in the chat, you can unmute and tell us. She's leaving us in suspense. She said, I got, and then she, dot. Kyle Kelly, what do we get? 1/16, very good. Very good. And then lastly, squaring 1/2, you get, well, like 5/10, you get 1/4, very good. Or you could write it as 0.25. How many different numbers are there in this new list? 5, right? Because why? Why can't we say 7 this time? Multiple of the same number, because it's talking about how many different ones. We have a repeat here. Good job, Abby Wasta and Adam. Thank you for that. We have 2 9s. We have 2 4ths, 1/4. Good. So let's explain why. Why does this list have only 5 new outputs when we square them all? What do we think? Max says, because when you're squaring, you always end up with a positive number. Good. And because some of these were negatives, these were the same numbers, but one was negative, one was positive. When you square, you're always going to end up with a positive number. Good. Nice job on that one, Max. When you square a number, you always get it positive. I wrote pause and then num because I don't have space. Nice job. Very good explanation on that, Max. Yes, kiddo. Love it, love it, love it. Love it or list it. Nobody watches that show on HGTV? It's a classic. Listen, I'm not even anywhere near buying a house, but I always have an opinion. Definitely love it. Okay, let's take a look at the next piece of this, okay? I'm going to leave that explanation up just so that in case you didn't get a chance to write it down, you can get it down now. Yes, Cameron watches it. Woo! Yeah, Cam. Me and you, girlie. Okay, let's take a look at this next piece where we're talking about where the warm-up, where you have to square numbers, an example of a function. When you square a number, is it going to get me, is it going to be a function? If you only are choosing a certain domain and range, okay, good. But if we're talking about, if we were to sort of come up with a general rule, so if we say input right? And then our function machine is asking us to square it. And it's every single number possible in our output. If we're looking at it in general, is that a function? No, it's not. Very good. It's not going to be a function because we have repeats in our, because we have, why? What's the reason that it's not going to be a function? What did we say our rule was? It's not a function if we have what? Very good, because different inputs have the same outputs. And let's put some examples. 3, -3. We also had 1/4 and negative. No, it would be half. Sorry, you're right. 1/2 and -1/2 and 0.5. Good. Nice job. You don't need to write this piece in here, but this is sort of the a tool that we're going to be using when we're writing and looking at different functions. Is we're starting with our input, we put it in to our function machine, and then we have a rule or an equation, and then we get our outputs. Okay. I love that, Kim. Oh, putting things in the wrong spot today. Oh, guys, guess what? Ms. McCain and Ms. Blanc are getting new smartboards today. That doesn't really help you guys, but I'm excited. Let's take a look at this next piece here, okay? So now our learning targets for today, we have 2 learning targets that we're going to be focusing on today, okay? Number 1, I know, or I will know, that a function is a rule with exactly one output for each of the allowable inputs. So if it's a function, every input is only going to have exactly one output. That's number 1. Number 2, we know that we cannot have multiple inputs with the same output. That's another piece. I know that if a rule has exactly one output for each allowable input, then the output depends on the input. That one is a little bit more complicated in its phrasing. We're going to break that one down in our second activity. Okay? We're just keeping in mind this piece here. Every input has exactly one output. There cannot be 2 different inputs that have the same output. Boom. Okay, so now let's look at this example here. Okay, a person is 60 inches tall. Do you know their height in feet? You do? Okay. So you can move this guy over. We can say, actually, I'm just going to circle it with my pen because it makes a little bit more sense. So okay. So without doing work to it, do we know how tall they are in feet? What do we have to do, John? We have to convert the inches into the feet. Good. So let's look at these 2, we like to call them input machines, right? Or like function machines. So do the rules in the diagrams match the answers that we talked about up here? So we said yes, right? John said that we have to convert from inches to feet. Is that rule going to match what we have to do here? This guy is going to match that rule. Now let's look at this second rule. Divide by 12. Does that rule also attach or work for this scenario? Why do you say yes, Kyle Kelly?
Please call extension 3214.
Because you also get the same output, right? This means the same thing as this. this is stated in words. And this guy down here is more concrete, telling you exactly what you have to do. So this one, you sort of have to know how do we, nice job there, Gabe. You have to know how to do that. But if you were to write that for a rule, I would still say that it's correct. More specifically, you could say the rule is divide by 12. Okay? So both of these are going to work for rules because in the end, we're still going to get the same output no matter what input we put in. Okay, so if we put 60 into both of these, we're still going to get an output of 5. Feet. Okay? So now we're going to do some work on our own. Okay, so I want us to take a look at slide number 9 first. Okay, slide number 9 has a scenario on it. We're going to do 2 things with this scenario. First, we are going to say, can we find out their height in inches given the number of feet, like how tall a person is? Can we figure out how many, like their height in inches? Yes or no? That's number 1. Then I want you, just like we did here, to write a rule for this scenario. There are 2 ways that we could really write it.
Ramadan, please call in section 3.
And then I actually want you to plug the 5.5 in here and tell me what my output is going to be. I want you to take a minute and a half right now to, actually I'm going to take 2 minutes right now to do this guy here. I want you to tell me a rule and then actually calculate what my input, what my output will be when my input is 5.5. Okay, nice job there, Gabe. Ooh, look at that. Nice job. If you finish early, you can take a look at some of the other subsequent ones. Some of the subsequent slides, some of the after ones. Nice job, Peyton. She came up with her rule. I love it. Oh, John, question? No, okay, sorry. Okay, awesome job, everybody. Let's take a look at what we were getting here. Not a problem. Yes, you can do that, Cameron. Let me just message her. 1 second. Sorry, I'm sorry. That keeps beeping. I'm sorry. Awesome job, Gwen. Let's take a look at what we got here. Okay, sorry. Okay, let's take a look here. So let's think about this as, can you find the exact value when you do something to this number? What did we think here? Yes or no? Is this a function? Yes, because we can always, no matter what, if we plug a number in and we do what we have a rule, whatever we figure out our rule to be, we're always going to get a different output. Good. Let's think about now our rule. What are we thinking about for a rule? What are we thinking about for a rule here. Nice job, Abby Wasta. Let's see what Abby Wasta said. Abby Wasta said multiply by 12. I like it. What do we think? Did anybody have anything different? There is another one that you could say here. You could make it more broad, and you could say, nice job, Gabe, there. You could say convert from feet to inches. Yes, you're very good. Both of these would be acceptable. It might be a good idea to be more specific when you write your rules, though, in case you have to do it multiple times, okay? And in case you have to like describe it to somebody else, it might be a little bit clearer if you write it as multiply by 12, but I would accept convert from feet to inches as well, okay? So now what would be my output here? Junior? 66 what? Inches, very good. Fantastic. So now what I want us to do is now I want you to take these concepts here. This idea of first, can you find the exact value when you're given this scenario? I want us to take a look at the subsequent few slides here. I believe there are 7 that we're going to be doing here. There's a lot. So I want us to look at, I'm going to give us a solid 7 minutes to look at these 6 different guys here. So slide 10 through 15. I want you to look at slides 10 through 15, come up with a rule for it if you can. And first you need to tell me, is it going to be a function? Can you find one exact value based on that scenario? Okay. Hint, there are going to be a few non-functions. So just keep that in mind. If you have a non-function, then you don't have to write a rule for it, obviously. Okay. So I want you to take 6 minutes right now to work on these 6 slides. If you have questions, put them in the chat. Nice job. Let me see who that was. Sorry, guys. Oh, let's come back. Well, I can come back. 1 second, Naseem. So it would be, so let me show you how we got this, right? So we would say 5.5 times 12. If you grab a calculator for yourself, 1 second, Naseem. 12 times 5.5. We get 66. Jessica? No, she's in, oh, she's the next one. Does that make sense, Naseem? So you would multiply 5.5 times 12. Nice job. Okay, nice job, Peyton. Sorry for catching that so late, Naseem. I'm sorry, buddy. Your class selection.
Did you do it last night? So you're good. You submitted it. Okay. Thank you.
Awesome, thank you. Also think logically about some of these, like for number 5. Can you find the exact value there without being given something? Yes, exactly. Yes, Peyton. Sorry, let me be specific. Yes. The last one is kind of tricky. Six does have a rule, but you're right on 5. Awesome job. We're going to come back together in about, please don't rush, 3 minutes. If you finish early though, let me know because I feel like you guys are doing okay-ish with this. But I'm not going to rush if I don't have, I mean, if we finish way early, I will. That's 4, 3, 2. Yes, Nassim, you can go to the bathroom. Ooh, I like that. Okay, so just an FYI, I'm not gonna rush through this, but I'm going to probably go at a little bit of a clip just because I feel like we're doing okay with it. But if at any time I'm going too fast, please let me know, okay? The only reason I'm picking up the pace is because I think that we can do it. But if you can't do it, please, please, please let me know, okay? Because this is me reading the room, and I could always not be good at reading the room. I'm never good at reading the room, really. Okay, we're taking another minute and 13, please. If you finish, please let me know. And then we're going to get started. Oh, I know they are hard, aren't they? I think 7 is probably the hardest. Okay, wonderful, wonderful, wonderful. 35 more seconds, my friends. You're doing great. Oh, so if you circle no, then you're not going to write anything in these boxes here because you're not going to be able to. There's not like one specific rule that will get you there. You know, those last 2 are pretty hard. Okay, so let's start to come back together. There we go. Let's take a look at these guys here, okay? So we're going back to slide number 10. A number is 5. So we have a number 5. Do we know what the square of that number is? Is it going to have one specific number? Yes, very good. So we can say that this is yes. We are going to be able to figure out what that square is. So we input our 5. Our rule is what? What is it telling us in that description that we have to do? square the number. And what's my output going to be? Gabe says, very good, or multiply the number by itself. Good. And then our output is going to be 25. Do we agree with that value for the output? Do we? Yes, very good, because 5 times 5 gets me 25. Very good. Nice job on that one. Let's take a look at slide number 11 now. The square of a number is 16. Do you know the number? Can you say for certainty one specific number? It is this number, 100%. Connor's saying no. What are people at home thinking? People are saying yes. So Connor is saying no. And Connor, let's see what Connor's explanation is here. Why are you saying no to this, Connor?
Because if 16 squared, you would obviously know that one of the answers would be 4, the other one also be negative.
Very good. So you could have an input here to get an output of 16, and you're squaring the number. We could have either the number 4 squared is 16 or the number -4 is 16. It's not, I am not asking you here, is this a function? I'm asking you, well, actually, yes, it is not going to be a function as well. So I'm asking you, can you figure out that one number that it could be? In this case, we can't because it can be either 4 or -4. Does that make sense, you guys? Because we're saying the square of a number. So it's a number x squared is the rule, is going to get me an output of 16. Is 16 means that you plug it in for your output. We're not going to plug 16 in for that input. We're plugging it in for the output based on the layout of this sentence here. We're saying a number squared is going to get me an output of 16. We don't know if it's going to be 4 or -4. So this one you would write no, and then you wouldn't really write anything in down here because this is a non-example. Okay. Let's take a look at the next piece of this, okay? Okay. We have the area of a square. Important piece here, square, has a perimeter of 12 centimeters. Do you know its area? Because we're talking about a square, can we say that we know the area if we know the perimeter? When we talk about a square, what do we know about the sides? They're all equal, so they're all equal to x, right? It's not like an x and a y. So to figure out our side length, given the perimeter, what would we have to do? X times x is equal to 16, right? Because that'll get me my perimeter. Or no, 4x is equal to 16, sorry. Oh, 12, oh my goodness. 4x is equal to the 12, right? Because we have 4x is our perimeter, and this would be for the perimeter. The perimeter is equal to 4x is equal to 12. You can calculate that x by dividing by 4. Dividing by 4, x is going to be equal to 3. So once you do that, once you get that side value, what did we think about for this one here? Is there going to be one exact number that we can calculate? Because we're talking about a square, there is going to be one exact value that we can calculate for that area of the same square. So the input here is going to be what value? It's going to be 3 because we calculated that side length. Good. And what do we have to do to get that area? X, very good. X not multiply by 2, but it's x
So,
times itself, x times x. And so my output is going to be what? What's my area going to be? What's my area going to be?
oh,
Nope. X times x, 3 times 3? 9. Very good. Squared centimeters. Good. Nice job, Abby Wasta. Okay. So another way that we could say this, another rule that we can put in here is we can say, if we're talking about it more broadly, we can say side length and you square it, right? Side length squared. If we wanted to put it into words. Good. Nice job there. Awesome job, guys. Let's take a look at the next one here. This is probably one of the more trickier ones here. If we know, now we're talking about a rectangle and it has an area of 16. Do we know the side lengths of that rectangle?
no.
Let me know in the chat. What did you think for number 5? If you have a rectangle with an area of 16, do you know its lengths, its side lengths? Yes or no? Let me know in the chat. Nice job, Peyton. Nice job, Max. Nice job, Gabe. Max, can I have you unmute and can you tell me why? What you're thinking there, my friend?
You can't know the lengths because it's a rectangle, so not all sides will be equal.
Very good. You could have side lengths of 8 and 2. You could have side lengths of what? We're talking about area of 6 times 12 is not going to get me 16. 4 and 4. We could have 16 and 1. So this is not going to be an example here because there's going to be like multiple values that it could be in here. Okay. Nice job there, my friends. So when there's nothing, when there's no here, you don't have to write anything in this bottom section here. Let's take a look at 14. Okay. You're given a number. Do you know the number that is 1/5 as big? So you're given a number X. What are you doing to that number? Kyle? It's saying 1/5 as big, so it's not going to be adding 1/5. It's going to be multiplying by 1/5 times 1/5. Can we, if we're given a value here, if we're given a number X, can we find an exact output?
Yes.
Yes, we can, because we take that number and we multiply it by 1/5. Very good. So we would say yes here, and then it would be 1/5 X. For example, if I had an input of 5, plug it into my function box, my function tool, function machine, if you will. What are we going to get for an output? It's going to be 1. Very good. Take this value, this input, do this to it. You get an output of 1. Very good. Nice job there, Connor. Nice job there, Gabe. Fantastic work, my friend. Okay, last one here. This one was probably the most difficult. You're given a number. Do you know its reciprocal? So what does a reciprocal mean? The opposite or the, if I have, like, for example, the number 5, what would be the reciprocal of 5? Now, when you say opposite, it makes me think I'm going to make it into a negative. But what is a reciprocal really? Not exactly. That we multiply by the reciprocal to cancel out, but it's the flip of that value. So 5 can be written, very good, Ian, very good, Gabe. 5 can be written as 5/1. The reciprocal of that would be 1/5. if you have the fraction 2/3, what would the reciprocal of that be? 3/2. Very good. Nice job there, Max. Fantastic. So when we're talking about the reciprocal, you're taking that value and you're writing it over 1. So your input is going to be x, because we don't know what it is, it's some number. And the rule, what would the rule look like here? Ooh, nice job. Gabe Sorelli said divide 1 by your x value. Good. You could also write it as 1 over x. So if I have this here, my output would be written as what? We don't know a number. So say we put in the number 4 here. What would be my output for this guy here? 1/4. Very good. 1/4, or you can write it as the rule of 1 over x. Very good. Nice job there, Gabe. Nice job there, Connor. Fantastic. Let me tell you what we're going to be doing for the last, we have about 2 minutes right now. I want to take 2 minutes to look at one piece of this, and we're going to finish it up tomorrow. So, okay. So let's look at, we're moving to slide 16 here. A person is 60 inches tall. Do you know their height in feet? Written in function language, this scenario written in function language would be the height in feet depends on the height in inches, or would it be the height in feet is a function of the height in inches? I don't know why I'm underlining the wrong things here. So if we're talking about this scenario here, where we're talking about a person's height, a person's height is 60 inches. Do we know the height in feet? So if we're turning that into function language, we're going to say that the height in feet is a function of the height in inches, because the output is the height in feet is a function, is related to its height in inches. So it's going to be this second option here, because yes, the height in feet depends on the height in inches, but if we're talking about it in function language, we're saying the output is a function of that input. Okay, function language, when we're writing about these guys, we're going to say that the height in feet, or the output, is a function of the input. Okay, very good, Gabe, on that one. Very good. So this guy is going to be our winner, because we say the output is a function of the input. Okay. So give me 30 seconds before you leave for Spanish. I'm going to give you a rundown on what we're going to be doing tomorrow, and then we're going to go from there. Okay. Tomorrow, I don't want you to turn these slides in, because we're going to come back to them tomorrow, and I'm also going to assign like new ones. So we're going to cover this between tomorrow and Wednesday. Okay, so we're writing now, is it a function? Why or why not? So we're going to be looking at 7 different scenarios, and we're going to be using that definition of a function, and we're going to be jumping in, and we're going to be deciding, are these functions based on the story here? Okay, awesome job. So that's what we're going to do tomorrow. You don't have to do anything there. We're going to finish this tomorrow. I'm going to push the extension date on this. Please do not turn it in. Okay, if you look at your homework on slide 22, you need 20 minutes of Alex time today in the afternoon. Okay, so when you get home, maybe if you want to do it during lunch, you need 20 minutes of Alex time today. Okay, does that make sense? Okay, so everybody, I'm going to be checking in. I can check that column like I told you for today's hours. And I'm going to check to make sure that you have 20 minutes completed today. Okay, friends that need to go to Spanish, you guys can start to head out. Please do not forget about the homework. And friends that do not go to Spanish, please stay in. And we're going to be logging into Alex for this morning. Okay. You already did it? Yeah. So why don't you get in and try to get your 30 done for the week? So that later on in the week, you can, if you didn't finish all your topics, you can focus on those. Oh no.
What?
It's like funky dunky. We're gonna open this. There's a fly in there. If it gets too cold throughout the day, obviously you guys can close that, but I just want to sort of give us some freshy. Okay, perfect. So my friends at home, let's log into Alex, make sure that we are getting some of our time done. This can count for your homework time, so let's make sure that we are focused and on and getting things done. Remember how that thing progresses or the timer progresses. And yeah, I'm gonna stop my recording.